Now you see, so these are the examples of task relations. These are the one after the other, the successors. One is a predecessor of two, which is a predecessor of three, which is a predecessor of four, five, six. All these are task IDs. Task IDs are coming from here. After the database is tested, everything else is done. Our database is tested. For example, after the database is tested, then 7, 11, 16. What are these? The parallel activities. So I've written these using commas. I've written these using commas. Why? Because these are parallel activities. The parallel activities is are. So the requirements analysis of the other modules. Now you see, although these are actually parallel activities, that means they can be done in parallel with each other. Now let us say that we have only one team doing all the requirements analysis. In that case, 7, 11, and 16 may not be, these may not be parallel. For example, if the teams that are available, if they're doing 7 and 11 and 16 all, then this could be that you will write like this: if there is not Nishant, if you pay attention, this is 7, this is 16, sorry, this is 11, this is 16. The requirements analysis of the other modules. Please pay attention, Nishant. Now, if there is not enough human resource to conduct 7, 11, 16, etc. parallelly, that means we don't have enough people to do all the requirements analysis together. So we are doing it one after the other. So like this, we sort out which are the successors and predecessors. We also sort out which are the parallel activities, that way. Then we also infer, or rather impose constraints. Like for example, time. Say 1, 2, 3, 4, 5, 6 are database. For example, we do say 1 week, then 2, say 1 week, then say 3, we give 1 week, then 4, we give 1 week, 5, we give 1 week, and for testing of database we give 3 weeks. Let us say now what will be the constants. So this is a time constant. So time constant, we are actually setting some time. So this is week 1, this is week 2, this is week 3, this is week 4, because these are, you see, how do we do that? This is one after the other, it is coming. After 1 comes 2, then comes 3, then comes 4, then comes 5. Because these are, if 1 is not finished, 2 cannot start. If 2 is not finished, 3 cannot start. If 3 is not finished, 4 cannot start. 4 is not finished, 5 cannot start, etc., etc. So if 1 is in the first week, then 2 will be in the second week, 3 will be in the third week, 4 will be in the fourth week, 5 will be in the fifth week, and 6 will start from the sixth week and go up to 6, 7, and 8 weeks. So this will be the 3 week from the fifth week. The fifth, sixth, and seventh week. So, sorry, sixth, seventh, and 8 weeks will be task number 6. So automatically the constant is 1. Let us say that we have a real constant on that number 2. What is the number 2? Say normalization or say design. Let us say design. By set database design has to be finished. Database design, which is third, this is design. Let us say that 3 has to be finished So has to start at by week 3, has to finish by week 3 end. That means one total week, not more than that. Let's say this is all. So that means this activity cannot take more than 1 week, and this will have to be starting at the start of the week 3, and by the end of week 3 this activity will have to be finished. This is also a constraint. So in that case, how are the other two going to be affected? So number 2 will have a constraint, has to sorry finish by week 2 end. Why this constraint is imposed? This is imposed because of these constraints. It cannot start before 2 has finished, and it must start by the start of week 3. So this must stop by 2 end, week 2 end. So this is called a must finish on constraint, and this is a must start by constant. This is a must finish on constant. Okay, like this. What kind of constants are there? Let me use a separate color for the constraints. So the constraints are must finish or start on, must sorry, then you have a start no earlier than, for example, for 2 there is a constraint start no earlier than the finish of 1. That means unless and until 1 is finished, 2 cannot start. Start no earlier than the finish of 1. So start no earlier than or no later than. Then uh, this is the main must finish or start on. Start no earlier than, start no later than. Then you have hang on. Then you also got uh, say finish by is a loser, or start by. What is the difference? There is a must finish or start on or by. What does that mean? That is the difference. On means on particular date. By means by some. We generally say by the end of this week. The end of this week can be 2 days also. Means by end of this week I can say when it is Saturday, I can also say if my week is from Monday till Sunday, I can say if someone is starting by Saturday, must start on Saturday. I'll say finish by the end of this week. You must finish by the end of this week. Can be Saturday, can be Sunday, but most is Sunday. And when I say on, I say must finish on Saturday. That means exactly on that date. So on and by, this is the difference. Now finish by and start by, there's a bit of a difference between these two. So this is a suggestion. Right? I can tell you, finish by end of this week. You may take this as a okay an advice, a strong advice. So I must finish because son must have some plans. But then if I say must finish on, must start on, that means actually on that particular day. So these are the kind of relationships that there are. So work predecessors, etc. Then you also after this decide on the type of task. What do you mean by type of task? Let's see. So tasks can be normal tasks or milestone tasks. Actually, we should say non milestone tasks or milestone tasks. For example, let us say you are doing requirements analysis. What is involved in that? First of all, you have the requirements engineering process, that is requirements gathering, requirements sampling, requirements solicitation, requirements prioritization, and then you will have SRS, which is the software requirement specification document. SRS. Out of all these tasks, there will be back and forth traveling between these two. So we gather some, sample some, elicit some, prioritize some. Then some new samples appeared, some new requirements appeared. We gather them, we sample them, we elicit those requirements, and we prioritize those requirements. For once everything is complete, when all the requirement analysis tasks are complete, only then we form SRS. So thus, SRS is a milestone task. What is a milestone? So when we talk about a milestone, okay, so what is a milestone? A milestone, it just indicates how many miles when you are going on the road. A milestone indicates how many miles you are going or how many miles you have covered. A milestone will never appear before a mile. Now you see, milestones are a general term. Actually, in India, for example, we measure in kilometers. So they're actually kilometer stones, but they're still called milestones. When we do some really important work and it's finished, we say that we've reached a milestone in our life. What does that mean? We've reached a certain degree of completion. We've reached a certain degree of achievement. That is a milestone. So very similarly, when we talk about the SRS, we meant that we have done all the requirements processes and we have reached a certain point of delivery. Okay, that is, we are able to deliver the requirements to the customer. We are able to show it to the customer that this is final. So we have now reached a milestone. So these tasks which show that we have reached a milestone, so that is a milestone task. Is that understood? Okay. Now, once this is done, so after that there are certain things to do which are just we want to, if there are certain notes that we want to we want to set the project calendars and stuff. What are those? Let's see. We set, so other tasks, we set project calendar is what? 24 hours all time work. Okay. Then Saturday, which is Sunday off. Normal schedule. Normal schedule is what? Monday to Friday work. That means Saturday and Sunday are off. You can say the time units between weeks, days, months, etc. Software projects normally weeks. Get weekly reports and we get weekly reports. Then we set instructions on particular tasks. For example, there is a task number, say 19, integration with UI. So what will be the instruction of 19? For 19, instruction is UI must be ready. If the UI is not ready, then the middleware cannot be integrated with the UI. So it may be that the UI is finished before the server, before the middleware, or it may be that the middleware and the UI finishes at the same time. Whatever it is, for 19 to happen, UI must be ready. This is a instruction for 19. It's an example. We also said resources. Resource allocation is a very important thing. For example, let's say for 19, that is middleware integrated with UI. So we need to have the middleware and the UI ready. So we'll have to have at least say, let us say we have two computers, four test engineers, one analyst is ready, software analyst. Okay. Then let us say they have to be provided with custom transport if they need any stationery, even a small gem clip. So it must be mentioned. Only mention so that money or budget, money allocation or budgeting can be properly done. So remember, why do we need to do even this? Because everything is paid for by the project. Okay, so highly accountable. Just remember that, highly accountable. You're not paying anything from your pocket. No one will. It is from the project, and who pays for the project? The customer pays for the project, mostly, unless and until there is an exception. Everything, even a small gem slip, a small paper clip, must be accounted for. So the resources are set. We also have to decide two more things. Is it schedule or effort driven project? Okay. What is schedule or effort driven? Schedule means time allocated. Effort means person month. So are we going to go for calendar months? That means when we are going to sort out the chart scheduling chart, is the schedule going to be weeks or in man months? That we have to find out. This will be in days and weeks normal, and effort will be, as you know, in man months. There's a difference. You have to find that out. Another one is, we have, what do we have if there is a fixed something? Is there anything fixed? That means labor, time, cost, etc. These are three basic ones. Etc. means other also, other aspects. Is there anything fixed? For example, let's say there are 40 engineers working on the project and it is fixed. That means whatever we have to do, that work will be have to be done by 40 engineers. The time, let's say we can go anywhere from 40 to 400 engineers if we want to, but the time is fixed to say 15 days, etc, etc. Cost, whatever we do, we have to do it within say 10 lakhs of rupees. So is there anything fixed? Then there are other things also. Is there anything fixed in the project? That we also have to decide. Now once this is over, then we use the critical path method and CPM, that is using PART, which I've done in OR. So I'm not going to repeat what is PART and everything. So you just look up OR, and this is a critical path method network. Find the critical path in between the activities, and then you do a Gantt chart. For example, As you know, this is always the time, and these are the tasks this way. So let us take for example uh, what we did here. Okay, so we have 1 week each for 1 to 6. Okay, 1 week each, and 6 is 3 week and the others. So we will make the Gantt chart like this, and let us say that our time division is like this. Then we will more or less draw our chart just for the database. This chart is I'm drawing this chart. Sorry, this won't expand here. It's one, two, arrow is here. 3, 4, 5, and 6 expands to 3 weeks. Okay, so these lines, these are bars showing the tasks, expanse of the tasks, each, like 1 week each. Okay, you may have the date also if you want to. So these are the arrows. One after then, these arrows are what? These are the successor arrows. 4 is a predecessor of 5, 5 is a successor of 4, etc. 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 It's gone on to 6, and then some other, say for example 7, etc. You may draw the Gantt chart for each of the modules, or you may draw an entirely big Gantt chart for all the modules. It's called. Okay. Now this is it. Now say, why are these hollow? Because these have not been completed yet. Let's say we are at the middle of say week 4. So the middle of week 4, if this goes according to plan, then we have already finished 1, 2, and 3 we have finished, and 4 we have done up to half. This will be shown like this. These Gantt charts, the tracking Gantt charts, we can track the we can actually track the modules. We can actually track the modules. So how do we do that? These are filled up. This means these have already been finished, and this will be half finished. So only half of it is filled, the other one. So all of these are solid rectangles, solid bars, because they have already been finished. So they have already been finished. So they are solid bars, and this is finished only halfway through. Why? Because this half is still remaining. We are actually over here. This is our current time. We are in the middle of week 4. So week 4, 4 has been finished by half. These are all finished. And these are hollow because we have not started those yet. This is your tracking Gantt chart. Now this you'll have to do as part of the project management plan so that you can keep track of all these activities, how are they progressing. I'm going to end this meeting, start again.